Oh, in this experiment, we will learn how to measure the standard enthalpy change by a calorimeter, and these are set up to measure the energy and the enthalpy change. And what you need is that you should have a calorimeter, and then you should have some pipette filler, and some solution. And in this experiment, we will focus on the standard enthalpy change of neutralization between NaOH and HCl, an acid and an alkali. Well, first of all, we have to do some washings, and just through pipette and then wash by some distilled water. And then for the second pipette also, rinse it by using distilled water. And to remind you the technique, you should hold it horizontally and rotate it. And then release all the water inside. Oh, and then you have to wash each of these two pipettes with the corresponding solution. The first one is sodium hydroxide in 1 m. And the second one is 1 m HCl. And then after all the washing, we have to construct set up for the calorimeter, and it's just very easy. Just a beaker, and then a polystyrene cup with some cotton wool, and then just surround the cotton wool, surround the cup by the cotton wool. And can you tell me the reason why we have to use cotton wool and this polystyrene cup? Yes, they are good insulator. They can trap air so that they are good insulator of heat. Seems that too much cotton is used. And then just put it inside. Well, and then you have to transfer some of the acid, 25 ml of solution, into this beaker. And the reason why, can you tell me the reason why we have to use pipette? But the use of pipette is to transfer an exact amount, an accurate amount of a fixed solution. Say for example in this one, 25 ml. And you know the molarity of the acid is 1 m, so that when you multiply the molarity by the volume in the envelope, you immediately have the number of mole data. And because for the definition for standard enthalpy change for neutralization, we have to calculate it as the enthalpy change when 1 mole of water is formed from neutralization under standard condition, so that the number of moles matters. When all the acid 25 ml is transferred into this cup, we can cover it by using a net and then put a thermometer inside. And start from this point, you have to record the time until the thermometer reading keep on a constant. Now it should be 25.2 degrees Celsius. We have to keep on tracking its temperature to ensure that initially is a constant value. And you have to take the reading every 30 seconds. And it's now still 25.2 degrees Celsius. Until 3 minutes, you have to check, okay, the temperature is now still 25.2 degrees Celsius, so that you can proceed the experiment by extracting some of the alkali into the acid, we again use a pipette and then to get 25 ml of the NaOH. At sharp 3 minutes, you have to add this amount of alkali into the acid, and then at that particular moment you cannot measure the temperature. However, after the addition of the alkali, you have to measure the temperature and record it every 10 seconds for the first several minutes. So let's see the result. When the temperature now rises to 26 and 27 now. And then 28.8 now. 29.3. 30.1. 30.7, 30.8, and immediately after the addition of the alkali, just cover it and then record the temperature. It's now 31.2, and occasionally you can stir it. 31.4. 31.5, 31.4, 31.3, 'And you just keep on recording the temperature for 5 minutes and record it every 30-second time interval, and then you can stop. 31.2. Maybe I'll do in 30 more seconds, and then I will show you how to generate the data of the maximum temperature rise and then the energy release during the process, and how to do the calculation for the standard enthalpy change of neutralization. (31.1). Maybe I stop here and show you how to analyze the data.
After you got all the data points and then all the temperature, and then you can construct a table, and you have to convert all the time into second first, and then the graph you have to plot is to plot temperature against time as shown here. And this is the normal shape of this kind of analysis for an calorimeter measuring standard enthalpy change of neutralization. And then you can see several things is that at the beginning, because there is no any reaction occur before 180 seconds, so that the temperature remain constant at 25.2 degrees Celsius. And then at around 180, there is an increase in temperature. As you may see here, there is an increase in temperature, and it is because neutralization is an exothermic process, so that the temperature keep on increasing. And then finally, can you explain why the temperature will drop finally from 31.5 to 31.1? What happened here? The heat loss to the surrounding. is during the reaction or after the reaction occur, heat is still lost to the surrounding. So that this 31.5 is never the maximum temperature the system can get. It's because some has been lost to the surrounding already. So that the purpose of why we need to draw this graph is that we want to stimulate the situation that if there is no any heat lost to the surrounding, what will the maximum temperature rise be? Can you see the idea? And then what we have to do is just to extrapolate 去延長翻 the initial temperature. Okay, and then extrapolate it to 180 seconds. And then similarly, starting from the decreasing trend of it, starting from this data point, 31.5, and then we try to stimulate the situation that the system have no any energy loss to the surrounding. So we just draw a line to extrapolate this decreasing trend. And then the temperature rise, the maximum temperature rise is here at 180 seconds. What we want to do is this delta T. And then after you have the temperature increase data, you can actually plug in to the equation that the heat energy equals to mc delta T. And M here and C here means the mass and the specific heat capacity of the resultant solution respectively. And this energy is absorbed by the resultant solution. Is it okay? Well, and then if we want to calculate the energy that changed in the system, just very easy. We just convert it by adding a negative sign. And it's the energy change of the system. And then be reminded that what is the meaning of enthalpy change of neutralization? Is the enthalpy change when 1 mole of water is formed during neutralization, understand the condition. So that now we have the energy change of the system. What we left is that we need to calculate the number of moles of water formed in the process. And then by using this energy to divide it by this number of mole, and then finally we can get the answer. Delta H equals to negative mc delta T divided by the number of mole of water formed. And this is the idea. And the reason why we need to draw this graph is that to find the delta T term. That's it.